I'm Anil Kumar, and in this video we will explore different techniques which were used in this chapter to find slope of the tangent line. Basically, let's have a graph of a function here, and then we'll discuss different ways of finding slope of the tangent. Let us say there's a function which is kind of like this. So this looks like a cubic function to us, and let us say we want to find slope of a tangent at a particular point. So let us consider this to be the point of interest. So let us say this point is P for us. We need to find slope of the tangent line at point P on the graph. The technique which we have learned is that we can take any other point Q on the graph, right? So if we have any other point Q on the graph, in that case we can find the slope of the secant line joining P and Q. So if I connect P with the Q, okay, let this be the line, and let this be the point Q for us. So once I connect these 2 points with a straight line, in that case I can find the slope of the secant line PQ. So let me write this slope as MPQ as equals to change in x over change in y, correct? So, or we can say, let us say this point P is A for us and Q is some other x value. In that case, we could write the equation as, then in that case the value of the function at Q will be f of x, and at A it will be f of A, right? So change in y value, which is delta y, will be f of x minus f of A. And change in x value will be x minus A, correct? So that is the change in x value. And we can write down that the secant of slope of the secant will be f of x minus f of A divided by x minus A. So that is slope of secant. Now the idea was to find slope of the tangent. So to find that, what we do is we bring point Q closer and closer to point P. So instantly what we are doing here is we are approaching the slope of the tangent line. So what we say here is that when the difference between x and A becomes very, very small, and that slope of the secant becomes closer and closer to the slope of the tangent, right? So we say that the slope of the tangent at x equals to A at point A is the limiting value when x is approaching A. Do you see? Of when x is coming very, very close to A. And we could write the same equation, f of x minus f of A divided by x minus A, and that becomes the slope of the tangent. Okay? So what you observe here is that the point Q is now very, very close to P, and we say at this time, if I draw something like this kind of, right, so where P and Q are very, very close to one another, so that x minus A, this distance which was that much earlier, becomes smaller, very, very small. In that case, the limiting value of the slope of the secant as x approaches A becomes the slope of the tangent line, right? So that is one of the definitions which we have learned in this particular chapter, and we have seen how we could write this in different ways. This is also called difference quotient. We could also consider slope at x equals to A could be written as limit h approaches 0, where the other point is h units away from A, right? So x value is f of A plus h. So that is so f of A plus h becomes the y value, and f of A becomes y value at A, right? That is f of A divided by A plus h minus A, which is h. So the same equation could also be written here like this. In short, what we are trying to write here is we are saying limit where delta x, the distance between these 2 points which we are considering, is 0, and we are taking delta y over delta x, right? So any form you write the equation, it is basically change in y value divided by the change in x value, which in general we say difference quotient. So difference quotient is to divide, and difference is y2 minus y1, which you always write this as y2 minus y1 over x2 minus x1, delta x being, this just to understand, difference means this, right? So that is how you could actually find slope of the tangent at any given point on the curve, right? So that is algebraic solution. At times you might get a question which says find a point on the curve. So let me write down the question here now for you. We have to find a point on the curve where the slope of the tangent, slope of tangent, let me write tangent line is 2, let's say. So we have to find a point on the curve where the slope of the tangent line is 2. Now how do you do this kind of equation? If you are given a curve but no equation, so if you are given a curve, then what you can do is you can draw a line with slope of 2, right? So let us say rise of 2, run of 1. So we just draw a line here. So this line, let us say, has slope m equals to 2, right? Basically draw a line parallel to this and see where it touches almost a point, right? So we could say, well, I could actually draw a line on this curve parallel to this given line, which has a slope of 2, kind of like this, right? So I say, well, this line is parallel to the line given to us, and so this line should also have slope of 2, and the point which it touches is the point on the graph where the slope should be 2. We could also get more than one solution in this case. If I draw on this side, I may get a point here on this side, right? There. So that could be a point where the slope is 2 for us. Great. So likewise, you could find a graphical solution by drawing parallel lines. So parallel lines with slope of 2, and wherever it is tangent, that is the point which is the required point. So that could be one way of solving such questions. That is a very important question which we just discussed. Now let me give you or discuss with you the other functions which we discussed. Now till now we were working with a general function, but we could have functions like f of x equals to x cube, x cube, okay. We could have f of x equals to square root of x. Now in these cases, this equation, which is difference quotient, will take a form like m slope is equals to limit h approaches 0. And when we say x plus h, this equation will be written as x plus h whole cube minus x over h, right? So that will give us a general point. In case we want to write slope at let us say x equals to 2, in that case the equation could be written as square root of, since we wanted 2 plus h, do you see that, minus square root of 2 over h, where the limit for h approaches 0. So that equation, if you could rationalize and solve, you'll get the slope, right? You could also get equations in rational functions. For example, f of x could be given to you as 1 over x. In that case, if you want slope at, let us say, x equals to 3, then the equation will be limit h approaches 0, and you have to replace x with 3 plus h. So you get 1 over 3 plus h minus 1 over 3 over h. Now solving this equation, simplifying it, you can find slope at x equals to 3, right? So likewise, you could have different functions to work with. At times, you may even have a function, let us say a quadratic function could be 2x squared minus 3x plus 1. And let us say if you want to find slope at x equals to 0.5, at a point where x equals to 5, you can say limit x approaches 5, correct? And then you can replace each x with, we'll write fx plus h 5 plus h. So we could write this as 2 times 5 plus h whole square minus 3 times 5 plus h plus 1. So that is f of x plus h minus, plug in 5. So we get 2 times 5 square minus 3 times 5 plus 1 divided by h. So that will give you a slope on this parabola at x equals to 5. Once you solve, you'll find that h normally cancels out. Once h cancels out, then you plug in 5 and get your result. So likewise, we did a lot of examples where we could find slope. Now there were a few questions in which we could find slope of tangent line and then equation of tangent line. So if the question is equation of tangent line, in that case you can use the form y equals to mx plus b. You know the point, so you know x and y values. Slope you have got from there, you can substitute, get the y-intercept, and then you can write equation of line. Some of you can also use point slope form, that is y minus y1 equals to m times x minus x1, right? So you could use this equation also to find equation of tangent line, and that is your point slope form, right? So you could use point slope form to find equation of the tangent line. I hope this overview gives you a good understanding of the whole chapter. I have provided you with few links. You can check those links to see how exactly to solve these different conditions or different forms of functions and get the slope of the tangent line, and at times find the equation of tangent line, or even find a point on the curve where the slope of the tangent line is same as given to us. Enjoy your journey. Thank you and all the best.